we will be resuming now. I would like to present Mr. Nok Chan, a senior software engineer dealing with Quantum Black and AI by McKinsey. Please give a round of applause to welcome Mr. Chan.
Hello everyone. Thanks for having me today. How many of you were you like in the last section here?
Last session.
Yeah, a couple of you. Yeah, I find it quite interesting because the last session was actually talking about how to use PySpark to debug, and now here I'm telling you not to use Spark. I see the two speakers not here, so I'm fine. But yeah, so the topic is really talking about like what are the alternatives for Spark here, and like do you really need Spark for everything? A little bit about myself. I'm a software engineer, currently based in London. I work for a consulting company, but I work for an open source project full time, which is called Casual. It's an open source Python-based pipeline framework. I did a presentation 2 years ago in PyCon Hong Kong as well. If you're interested, feel free to check that out. But I'm not here to talk about Casual today, so don't worry about that. Cool. Just setting the scenes a little bit. Like two of these scenarios, like I don't know if like it's familiar to you. Like it happens to me like both. Like examples are like I'm handing off like data pipeline written in pandas or in a notebook at the end of the project, and then I have to hand over to like some engineering team that hoping that and pray them like actually help me to rewrite in Spark and go for productions. On the other side, like if you're a data scientist, I don't know if you ever like pick up like a random Spark pipeline from other people, which is like processing a few CSV data, and then like you can use that for some analysis doing in a notebook or in scripts. I don't know if that resonates to you, but that's I've seen this quite a couple of times. So why is Spark so popular? I think this has a lot to do with the big data movement, like happens like probably like decades ago. It was really designed for big data. There's so many definitions of big data, but for now, like let's just define it like anything that doesn't fit on your computer. Like you cannot compute it on your laptop. That's big data, like for simple. And then like the second reason for that is Spark is kind of a safe choice. Like everyone's using it, like everyone's talking about it, so why not? And it's also like part of the infrastructures of many data platforms like Databricks and like similar to that. If you're actually not using PySpark on this platform, like you will hit like quite a bit of integration problem just because they make like PySpark the first class citizens for their platforms. So there's quite a few reasons for Spark being popular. So this is like usually how people start moving from pandas to Spark. Like you try to do whatever you do locally, like until like you hit like out of memory error, and then maybe you try to chunk your data a little bit, like split the data frame into like a few steps, and then hope that you can still manage to process the data locally. But you will hit the boundary at certain point, like where like you just have to give up and use something else, and that's Spark. Like Spark is really great for doing big data processing. It's really quick, and it can almost scale like indefinitely for most of the workload that normal people would deal with. Like we're not Google, so we don't have, I don't know, terabytes of data like in my company. But the problem is like Spark is increasingly become like a hammer in the data space. Like when you have Spark, like you feel like you can use Spark for everything. Like everything looks like a Spark job. Like even you have the CSV data, like you just do like a field filtering process. So why not run Spark on it, right? But actually in the space, especially in the recent years, like there's many new tools that is doing a lot better than Spark, like which could be like suitable for like different scenarios. So today I'm just going to go over this with you. Interestingly, there's a blog written by Jordan which used to work in Google BigQuery. So during the time he did an analysis on all the queries that run on BigQuery. And what he found out is that over 99% of the queries that runs on BigQuery, actually they're smaller than 10 gigabytes. So what it means is that actually many of these workload running on BigQuery, they don't really do that much. Certainly you can process that just in your laptop. You don't even need Spark or anything similar to that. And the reason that might justify this is that data is not really increasing as fast as we expected. I think it makes a lot of sense in this LLM world. We used to think that we can just keep dumping more data and then model will improve magically. But people are more realizing it right now. You actually need good quality of data instead of indefinitely scaling your data. So even though you have more and more data, it doesn't mean that you need to use all of them. And the second point about this is that your storage of your data is probably increasing, just like your photos that dumped in your Google Photo. But doesn't mean that you're going to look at them. Most of them are garbage. You never go back to look at them. And it's similar to whatever data you have in your organizations. You have a lot of data accumulating in your storage, but you don't really need to process them every day. Most of the historical data are not that relevant. I think this makes a lot of sense after COVID, because if you're doing any time series forecasting problem, you basically after COVID, you just dump everything that happened before 2019 or so, because they're more like noise than anything. So apart from that, what really happens after the big data movement, maybe it's helpful to review a little bit in the last decade what actually has changed. The first thing that has changed, which is probably more influenced by the cloud movement, one thing that we have now is the separations of compute and storage. In the past, database is something that we think we should use to process data. But nowadays, when you use Spark or anything similar to Spark, Spark itself doesn't handle the data at all. It's just reading data like PyCon file, which store in an S3 storage. So Spark itself is not really concerned about the data. The data storage itself is its own thing. You can basically scale them separately. And as a result, this really accelerate all the tooling that's built around this. For example, Spark or DuckDB, Pandas, or Polars, all of them can handle PyCon quite reasonably well. And these two, they only have to focus on optimizing the performance. They don't have to care about how to actually deal with the storage format. And the second point about here is one thing that we realize is that it's a much better idea to store data as a column rather than rows, for analytical workflows. It's much more efficient because now you can actually filter your data based on your columns. You can do partitions by time. So even though you have a huge table span up a few terabytes, for your own analytical workflow, the chances are you're actually just querying a subset of them. So it's much more efficient compared to the old time where you have to scan the entire table and try to filter stuff out. And the third point is the definitions of big data actually shifts every day as well. This is the spec of my laptop, and it's actually decently well. I have used a Spark cluster, which is actually having similar spec compared to my laptop. So things that I do 10 years ago, I have to use Spark for it. Now I can really just load it in my computer and literally just run it. I don't need Spark anymore. So this is something that's simple, but people are not realizing as much as they should. And the last point about it is in that space, now there's actually a lot more players join the game. Now you have DuckDB, you have Polars, which are all focused on single node processing. So unlike Spark, Spark is distribute. You have a big cluster, you try to scale your workload into different machine and try to do them efficiently and get whatever transformation you need. But DuckDB and Polars is really focusing on the single node scenarios. And unlike Spark, they are fairly lightweighted. So the only thing that you need to do and start playing with it is literally just pep install it. And therefore, like for deployments or like for anything that you actually need to use it realistically, it's very simple. Like you will never go to Google and like try to figure out how to deploy like a Python program, because they all look the same. There's nothing specific about it. As long as you can run Python on a container or on like a VM, then you kind of figure out how to deploy DuckDB or Polars. You don't have to like take care about cluster and everything like that. And the last thing, there's also new requirements coming into the space. We now care a lot more about data validations. I think there's a Lightning talk later, like actually talks about data validations. It's increasingly become a norm within the data engineering space. Unfortunately, Spark is really it's like a distributed computing stuff, and it's very slow if you try to do small data. Like it's very good if you're trying to process big data, but if you're just trying to read like a few megabytes of data, it still takes a few seconds. And if you think about in the context of running unit tests, like if you take 5 seconds to run a test, it's really not acceptable because you have hundreds of tables. It just takes forever. So in addition, although there are many things changed in the space, but at the same time, there's also still quite a bit of things still there, right? Like the old SQL database, Oracle, Postgres, MySQL, like they're still here. They're probably gonna be here like for the next 50 years. So now you have like another problem, like performance is not always your own concern. You also have to think about how to integrate with different systems. Like this space is getting more and more crowded. You're now like on this slideshow, like you have 8 or 10 things. Like in your production system, it might be more. So you have to think about how to actually maintain them like in a realistic way. With that, you now have like a unique challenge of you really want to pick the right tool for the correct workload. Like if you are handling like really big data, like you're handling terabytes of data, maybe you should use Spark. But anything like within like a few hundred gigabytes, you probably don't need Spark. And there's good reason to not use it. It's definitely cheaper to not use Spark. And it's faster. So there's like many different factors that you need to think about it. Maybe like a question for the crowd, like how many people here like a data scientist, data engineers, or ML engineer, that kind of thing? No one? Then why are you here? Students. All right. That's fine. Like it would be cool like if I can validate this idea, but like at least for me, like from my working experience, like I have been doing ML and data before I'm doing software. Like I have never deal with like customer data or transaction data that actually hit that scales that I have to use Spark. Most of the time, a few hundred gigabytes, like that's the maximal. I don't get 20 billion customer in my tables. Yeah, so the second point is like now you want to use the new tool, the new cool thing, but at the same time you still have the old stuff. You have the SQL stuff, and SQL like they're kind of standardized across different dialect, but at the same time they're not really that standard if you actually have played with different database before, and they're really hard to test. Like I just searched this on Google like a few days ago. Like this is like a sample that people teaching you to write SQL tests. Like I've never seen that in Microbase, like or like in Codebase that I've worked with. But the point is like these technologies that created in the old time, they're not fitting like the requirements of today. We need something that is a bit more developer friendly, so we can actually do this testing more efficiently. So for the rest of the presentations, I'm just going to talk about like 2 different tools that might help a little bit to mitigate the problem. So the first thing that I want to talk about is SQLFrame. So SQLFrame, the idea of SQLFrame is really, really simple. It is a PySpark drop-in replacement. So the only thing that interesting in this slide is this line, like where you have an activate functions. So this is the space that you need to decide what are the target engine that you want to run on. Like for example, if you want to run on DuckDB or you want to run on BigQuery. And the other interesting thing is that even though like you see all this import here, like they're coming from PySpark, but the output here is actually creating like a DuckDB sections. So this is the idea like how this library works. Internally, it just tries to patch stuff like dynamically so that you don't have to change any code that you have written. This is suitable like if you already have a lot of PySpark code written and you just want to run them locally, maybe because you want to run unit tests, but you don't really want to run PySpark behind the scenes. And there's nothing interesting about this query specifically. Like the whole point here is just showing you that this is just a normal PySpark query. Like you can run this directly on PySpark. But if you run this before that, it basically transforms the whole query. Like it will run in DuckDB instead of going through PySpark. And if you were here, like in the last session, you can actually see that Spark itself is the base. Like it comes with its own stack. Like you see that it has its own. You need to learn specifically about optimizing Spark. Debugging Spark is not like debugging any Python functions. So there's a lot of complexity here. Like so this could be like a simple choice for you if you're not really dealing with that kind of scales of data. And the second things that I want to talk about is a library called Ibis. This is how they describe themselves. They call themselves the portable Python dataframe libraries. So what it really is, like, the idea is quite similar to SQLFrame, and it's actually a project that developed much earlier than that. The idea is that it's trying to be the unified data frames for any backend. So that includes data frames, that includes SQL as well. So the idea is that like you only write code once in Ibis, and then you can decide like at runtime where you actually want those computations to be. If you already have the data sitting in a Snowflake database, you don't want to just fetch the data into your computer and then process in pandas. Why not just compute it and then fetch the result? It's much more efficient. And a lot of time, like fetching data like that also costs a lot of money if you actually look at the bills. So you really want to keep the data where it is, like unless you have to do it in other places. And so just to give you like a brief overview, like this is the backend that Ibis support currently. Most of the common database are here, like I think, yeah, it used to actually support pandas, but it just dropped pandas like in the last version. And the reason is that DuckDB is really now like a complete replacement for pandas. So there's no point of using pandas as a backend. You can still output your tables as a pandas data frame, so you can do your plotting, you can do your stuff like that. But in terms of purely transformation logics or like computation, like pandas is no longer like that relevant in this space. So to give you an example, if you have used pandas before, like most of this stuff should be quite familiar to you. On the left, you have the input table, which is like a fairly simple table. You have 3 columns, names, height, and mass. And the task that you do here, like you basically want to filter by height and then sort it by the mass columns. And what you get is the tables on the right. So in pandas, you would do it like this, and then in Polars, you have a syntax that looks a bit more like PySpark, and then like you have PySpark like in the bottom. So one simple query, you already have 3 different ways of writing this. So just think about like how could you maintain that like if you're actually writing code like in a big code base. So Ibis have its own data frame API. It actually looks quite similar to PySpark, but there's subtle difference. Like you can see that, for example, the older bright here, like this is more like the Java world of naming stuff, and Ibis is more like the Python style of naming. But what happens here is that when you write code in Ibis, you can choose the actual computation engines. So this is just something that you write, but Ibis itself doesn't do any computations. It will make sense a little bit later. I will explain it a bit more. And this is just another example to illustrate the problem. So if you're a Python developer, you use DataFrame like as a default, but there's still quite a lot of people, they do data engineering, or like they do like ETL pipeline, but purely in SQL. Like there's like another school of like SQL-based pipeline if you have used dbt or something like that. So here just showing you that like something that kind of simple, but if you have 4 different databases, like they all look different. Like if you try to code this yourself and try to refactor this yourself, you probably end up with something that kind of looks like this. And you really don't want to do it because it's kind of ugly. But if you're into the school of like writing Ginger template with SQL, this is more or less like what you would get. So again, like if you try to do that in Ibis, it will always be the same. So it can compile and translate to like any engines that you can run a query. And this is an example to just show you a little bit like on the developer experience side, like how does it actually works, or how does it feel like when you're writing a query on Ibis? Like at the top, like you have what you would write in SQL. You're trying to, play with the bracket a little bit, go back and forth. Like it's kind of annoying. If you have like better IDE, then maybe it's better. But normally for myself, like I do prefer like using a full programming language. Like so you get stuff like auto completions. You can chain functions like relatively nicely. Like if you don't want to see them like on the same line, like you can separate it like line by line, so it's kind of look clean and nice. And it also much more debuggable. Like the things on the top, like if you're trying to set a breakpoint, like you can't do it. Like because SQL is a declarative syntax. There's nothing that you can put a breakpoint here. But the things like in the bottom, like if you try to put a debugger, like you can actually step in like in any time that you're interested. So in terms of like development workflow or like debugging experience, it's much nicer if you stay within like the Python space. So the same problem goes with PySpark. Like just now you've seen like you actually have to go a few hops like to really debug a PySpark query, because you're going from Python world and then you go to the Java world. So there's like a lot of complexity involved if you go out to the Python space. And to explain a little bit more, like this is actually what happens behind the scenes. So for example, like if I have a table and I like kind of like select 2 columns, internally like Ibis actually build like internal representations of the whole thing. So when it needs to actually compute the data, when it needs to send the query over, for example, Snowflake, it will like transform that whole expressions and then compile it into different SQL dialects. So that's how it works behind the scene. If it's Oracle here, like then the syntax may look slightly different, but that's all happened behind the scenes, so you don't have to do that yourself. And this is just one more example to show you it's quite flexible. Like normally you won't do this, but here like it's kind of a strange example. On the left you have something that looks pretty like SQL. On the right you have something that looks like Python code, but you can actually combine them together because Ibis internally store everything as expressions. So you can kind of mix SQL with DataFrame code together. It's not something that you would do, but I just show you like how flexible it is. And I just want to explain like how the concept of Ibis work. Like so when you're actually running a transformation logic, by default Ibis is lazy evaluated, which means like when you write code, it doesn't actually compute anything. It's just trying to build an internal graph until you actually need the data. For example, you want the first 5 rows of data, then it will actually send over the queries and compute it. But other than that, everything is happening like lazy in the lazy factions. So for example, like if you're running some queries on a table, the only thing that Ibis would do in the beginning is that it would try to fetch the table schemas from the database so that it can get all the information about the columns, you can get all the completions, you can make sure the typing will always work. And then when you write the actual transformation logic, you try to aggregate data, you try to do whatever Python stuff there, like it will build up the expressions internally. And then at the end stage, when you need the data, the query will be sent to the execution engines, and then you fetch that result back to locally, like in a notebook or in a script to carry on with whatever you're doing. So yeah, this is pretty much the end of my presentations. So just a few recaps, like watch out for the single node ETL developments, like this guy in the middle. They're actually getting much more popular because if you have tried use DuckDB and Polars, like they're really quick, like compared to pandas. So even if you don't want to use Spark, or like you're just used to use pandas, like my advice is like check out Polars because it's like more like a data frame library. If you're more used to SQL, like check out DuckDB. And think twice, like when you're running a Spark job, like think about, do you actually need Spark? Like how big is your data? Can you do it something locally or like with less resources? Because Spark can solve everything. As long as you have money, you just put in more cluster, it always runs. But it's not necessarily the most efficient solutions. And there's like tools like Ibis or like SQLFrame that can help you if you want to make sure your pipeline can run everywhere, like so that you can scale differently. You can imagine it's like local workflow that start with Ibis, you can run in DuckDB, like if you're just developing something locally. But when you want to scale it to production, you can ask Ibis to convert that to Spark now. Like so, please like scale that as a Spark engine. So it's kind of like a convenient way that you can choose different engines, like when you are developing locally. Yeah, this is just a list of reference, and that's it. Thank you.
Thank you, Mr. Chan. We are now open for questions. Does anyone have any questions?
I wanted to ask about Ibis. So you say, unlike Spark or Polars, it's not limited by the volume anymore. But like besides volume, is there any other considerations you have to make when using this in data processing?
Yeah, I think like the first thing I want to clarify is that the idea that Ibis is not constrained by the volume, I guess you're referring to that graph. Like remember, like Ibis actually don't do any computation here. If you're on the space on the right, probably like the only players right now is Spark or something else if you're Google or Facebook. So what Ibis do here is really like transform whatever query that you want to run into Spark. So you're still doing Spark in that sense. But then like I guess like the other point that you mentioned, one of the other factors that you want to consider, like one thing that Ibis handle is that on the interface, on the syntax side, like the advantage of using Ibis is really you make sure you only write code once. You don't have to write stuff differently. You don't have to ask your data science team to write PySpark code, because I've never heard a data scientist like PySpark. So like there's a lot of frictions when you go into an actual team, like you have engineers which prefer something like in their own stack, and then like on the other side, like data scientists tend to use things that they're more compatible with. So like these are the factors that you want to think about. Yeah.
My question is, if I'm using Ibis for my data workflow over Polar, would the delay processing in Ibis enjoy the delay processing benefit of Polar?
I think that depends a little bit on what API you're using. Like personally, I don't use Polars that much, so I'm not that familiar with it. But as long as I remember, like it depends a little bit if you're using the DataFrame side or using the SQL side, because Polars also have like a kind of like a SQL API themselves. So it depends a little bit which things that you're actually using. But I guess it's, if you're using Polars already, like you need to think about why you need Ibis. If you have Polars, like you might not need Ibis, like, but the benefit of using Ibis is that now you can write things in Ibis, and then someday you can actually run this on PySpark. You don't have to rewrite it again. Yeah, I guess I don't know if I answered that question completely, but like for specific detail, like which part of API of Polars will work well with Ibis, like I don't have like a clear idea. Like there's definitely documentation on there, like you can check out. But one thing that I want to mention is that you can always fall back to the native engines, like when something is not supported in Ibis, so it's not like you will get blocked completely. So yeah, that's like a workaround about it. But most of the common logic, like is definitely supported there, and like stuff like UDF or like custom function is always supported. So there is workaround, like you won't get like stuck in Ibis if it hasn't supported certain functions in Polars, because Polars is always releasing new version quite quickly as well. So it's like a catch-up game there.
So if you're using a DuckDB or migrating over from MySQL to SQL databases to DuckDB or Polar, can you also use the ORMs like SQLFrame on the tool to define schema of the database?
You're talking about the migration process, or like the
Defining schema for databases.
I think what happens is that as long as you finish the migration, like now you basically moving from DuckDB to MySQL. So like for Ibis concern, now it's see a MySQL database. So it doesn't see DuckDB anymore. So there's nothing specific like about it. Like SQL Alchemy, I don't know which part of API or integration you're talking about, but most of the time, like Ibis work extremely well with anything SQL Alchemy compatibles. So I would say like it should be fine. Like if you check the code base, like if the backend actually supports SQL Alchemy, the code base in Ibis is like a lot smaller compared to other stuff. So most of the time, if it can defer to the engines, it would defer it. It doesn't reinvent the logic. It just try to handle stuff on the front, so you don't have to write all the glue code yourself. That's the main idea of Ibis.
Okay, thank you, Mr. Chen, for your time. Please give a round of applause for Mr. Chen.